Hey everybody, this is the Excel example for the IRR problem. We are going to just run through a quick example here. So we have the question right here. A new piece of equipment has been proposed by engineers to increase the productivity of certain manual welding operations. The investment cost is $2,500. So let's go ahead and put that in for the investment cost. The equipment will have a market salvage value of $5,000. So salvage value is going to be $5,000. N is going to be 5 years because it says the expected end of the 5-year life. And the increased productivity attributable to the equipment will amount in $8,000 of savings per year. So let's use a spreadsheet to evaluate the IRR of the project. This is not a number. So the first method that we can try is trial and error. Let's go ahead and put some discount rates in the guess. We're going to start with a moderately low discount rate, and let's increase it by 0.1. So we do equals this time plus 0.01, increase the interest rate by 1%. Let's get it down. All right, we got it down to 14%. So we can try that. Remember, we can always add additional stuff. Now, so we have the discount rates that we're guessing. Let's go ahead and make these percents. So to get the net present value of the project, we have, let's go ahead and put this cash flows in the cash flow diagram. So end of year 0, or end of year 1, 2, 3, 4, 5. Cash flow, capital investment, $25,000. So that happens at year 0. And then annual savings, $8,000. That's going to go for all 5 years. And then in the 5th year, we're going to sell it for $5,000. So let's get this to $13,000, which is the $8,000 annual savings plus the salvage value. So let's go ahead and figure out the net present value. So the net present value is going to be equals negative capital investment, right? We're spending the money on that, plus NPV, net present value of rate, and then comma these values. And remember, we have to lock a few of the cells. The only thing that we want to change is the discount rate. The rest of these we want locked. So there's that. Net present value, positive at 3%. All right. So we're still positive. Let's go ahead and continue to drag this down. Or let's go down to 30% just because. Okay. You can see this is where it crosses to negative, between positive and negative, somewhere between 21 and 22%. We can go ahead and plot it. So select the data. Go ahead, go to insert. We want the XY scatter. Go ahead and make it look like this. Delete the grid lines. We don't really need those. See, If you want to change the axis around and format the axis, you can. See minimum, maximum, major units and minor units. So let's go ahead and make the major units 0.01. Alright, that doesn't look that great. How about 0.02? So you can see that. See, again, crosses around 22%. So pretty good IRR. There is also a built-in Excel function. Personally, I think it's probably the better of the two options, provided that you understand. Let's go ahead and do the IRR. So for the built-in function, we need ends of years 0. So let's go ahead and move this down 0, 25, 1,000, dollar signs on that, equals IRR, cash flows. Select the cash flows, make a guess, can be any guess. The way it uses numerical methods to solve this, so in really complex problems, the more educated the guess, the better, but in this case it doesn't really matter. Let's try guessing 0.07. See, comes out to 22%. So remember, for the IRR, you need to use the end of year 0 cash flow, which is not the same as the NPV function, which you have to use ends of years 1 through 5 and then add the beginning calculation to it. If you want to see what happens if you make a different guess, let's go ahead and do IRR again. Select all these and make our guess. So the guess just helps the computer. It'll come up with a guess on its own too, so most of the time it's right. Let's do 50%. Still goes to 22. So IRR function, the guess is fairly forgiving in any of the stuff you're going to do in this class, because it's going to find a local minimum, and this only has one minimum, but in a situation where there's multiple minimums or maximums, then it's going to find the closest one, so it might not be the one that you want. Anyways, thank you for watching. If you have any questions, please let me or the TA know. Have a good day.